Equilibrium. A body is said to be in equilibrium if a number of forces acting on it do not produce any change in its state of rest or of uniform motion. When the body is in equilibrium, the algebraic sum of all the forces acting on the body is zero. Also, algebraic sum of moments of force, torques, is also zero. If a body is slightly disturbed, the body may come back to original state or move away from it. Stable equilibrium. A body is said to have a stable equilibrium if it returns to original position after being disturbed. If a cone is slightly disturbed, it returns to the original position. Unstable equilibrium. A body is said to be in an unstable equilibrium if the body is slightly disturbed. It tends to move away from its original position. A cone resting on apex falls down on being slightly disturbed. Neutral equilibrium. A body is said to be in neutral equilibrium if, on being disturbed, it neither comes back to its original position nor goes away from it, but occupies a new position very much similar to the original one. A rolling sphere or a cone rolling on its side are examples of neutral equilibrium. Archimedes' principle. Archimedes' principle states that whenever a body is wholly or partially immersed in a fluid, it experiences an upward thrust, that is, it loses its weight, equal to the weight of the fluid displaced by the immersed part of the body. Experimental verification. Archimedes' principle can be verified by bucket and cylinder experiment. Take a small cylindrical bucket and a tightly fitting solid metal cylinder. Suspend it from one arm of the balance. Put some standard weight in the other pan. Suspend the cylinder from a hook attached to the bottom of the bucket. There will be no change in equilibrium position. Now, take a beaker and fill partially with water. Place it below the cylinder and dip cylinder inside water completely. Care should be taken to ensure that no side of the immersed body should touch any side of the beaker. Bucket should, however, hang outside water. You will observe that equilibrium of the balance is lost due to some decrease of weight of cylinder dipped in water. Now, add water in the bucket gradually. When the bucket is just full of water, the previous equilibrium is restored. We know that the volume inside the bucket is the same as volume of cylinder. It follows that the loss of weight of cylinder in water is equal to weight of the water displaced by the cylinder. Thus, Archimedes' principle gets verified. Principle of balancing column. When we consider two columns of liquids of densities D1 and D2 at a fixed pressure P at depths H1 and H2, then H1 D1 G equal to H2 D2 G. D2 by D1 equal to H1 by H2. D2 equal to H1 by H2 into D1. Therefore, D1 equal to 1000 kilogram m to the power of -3. D2 equal to H1 by H2 into 1000, or density of the liquid equal to height of water column into 1000 by height of liquid column. The principle of balancing columns states that when two liquid columns balance each other, the pressure exerted by the liquid columns must be equal to one another. Buoyancy and buoyant forces. The tendency of fluid, liquid or gas, to exert an upward force on an object immersed wholly or partially in the fluid is called buoyancy. The upward force that acts on an object immersed in a fluid is called buoyant force. A body appears lighter when it is put inside a liquid. Take a body and suspend it by spring balance. Note the reading. Dip the body in a liquid and note the reading again. You will find the reading in the second case is less than in the first case. That is, there is some loss of weight or an upward buoyant force. Factors upon which buoyant force depends: volume of the body immersed, density of the liquid. Difference between thrust and pressure. Thrust, pressure. Total force acting normally on a surface. Thrust acting on unit area. The SI unit is Newton. The SI unit is Newton by meter square or Pascal. It is a vector quantity. It is a scalar quantity. Conditions of equilibrium of a floating body. Weight of the floating body must be equal to weight of the displaced liquid. Center of gravity and center of buoyancy must lie along same vertical line. Laws of floatation. When a body is immersed in a liquid, there are two forces acting on it. 1. Weight W of the body acting vertically downwards. 2. Upwards thrust W dash equal to weight of liquid displaced. The upward thrust acts vertically upwards through the center of gravity of the displaced liquid called center of buoyancy. If W greater than W dash, the body will sink. Iron, stone, etc. sink in water. If W equals W dash, the body will remain in equilibrium anywhere inside the liquid. Lactometer. If W is less than W dash, the body will start floating. Cork floating on water.